Okay, good afternoon, everyone. Please go to week 8 on your Moodle. Then download the CSV file and also the Jupyter notebook. Then upload it into your Databricks account and bring it up to this session. So we start our first basic complete project. So which we do basically a machine learning project over Titanic data set. I modified the data set. I randomly make some cells unavailable, so you see some missing values when you evaluate this data set. I give you a few minutes to download full files and then upload them into your Databricks account. Then we start from there. And as you might remember, you also need to create a cluster. Otherwise, you cannot process your Jupyter notebook. Also, regarding your second assignment, so presentation, 12 you had okay, almost all of you got 100. 12 you had okay presentation, but the remaining was disaster, really. I think if you get to if it's the level of your presentation quality, and if you want get to very competitive jobs, I'm afraid that you may have a very low chance. Having said that, please improve your presentation quality significantly. I give you more some presentation-based assignments, and from the next assignment, you also will be graded based on quality too. But frankly speaking, I was really a little disappointed of the quality. I hope when you do presentation in the job market, you will have the much better one. But with this level of presentations, I'm not sure what would be your application status, or how you could be when you want to do a job presentation. Okay, so today we do some basic data preparation. Look at the Titanic data set, and look at the first cell. You know, I have a picture, some note. It doesn't look like an ordinary cell. If you double click on it in the white space, you see that I put the MD in the beginning, MD tag, and after MD tag, so I think I want to put some comments, maybe some write-ups, and even look at the comment for the picture. So I put the picture title and also the direct link to a picture. I think it's a good practice for you to have such a thing in your final notebook that you want to submit. So you can add some pictures, put explanations. The tag I use is MD. If you Google it, you can find other ways of incorporating pictures for your notebook too. Yes. What's the click and make it disappear? How to make it back? Okay. So Shift Enter. You need to run the cell again. Okay. So as you see, putting MD tag helps you to put some write-ups. In case you want to add some comments for basically for some code blocks, you can just on the right side of each code block, just click on this icon, and you can add a cell up or below here. So in case you need to add some comments or have some blocks that is dedicated for your write-ups. On top of that, you can put hashtag and then write a comment in front of that. So here I said installing missing value package. Let's see what happened. Okay, with pip install, I can install the package that I want. So since I want to work with the missing value package, which helps me to do imputation, I'm install the missing NO package. Then I can later use this package for imputing my empty cells. Yeah, don't put it for pip install. Put the comments for other. Oh. Yeah. Okay, next we're importing Spark sessions, and then I put my application name. I put in my PROJ. Again, we are using one node, one project, so it's not that much efficient. But usually in practice, you are running several projects or several applications on your data nodes of Hadoop cluster. So you want to look at the progress of each application. So it's better to just put a name. So later you can find the progress of your applications. Then I'm importing the Titanic.csv file. This is the address on my Hadoop cloud. And I'm saying that with infer schema, it just means guess the structure of each column and also consider there is a header in my table. With data dot print schema, I can see what is the idea of PySpark about the structure of each column. So as you see, passenger ID is the integer, survived integer, pclass, name. So for example, sex is male and female. So the type or structure is string. And same for all of them. Then again, you see I have a text block, not a code block. And here I identified or define each column. For example, what does pclass means? It means a ticket class, or age means age in years. Ticket refer to ticket number, so on and so forth. If you double click, you can see how I made that. So with tag MD, I just said this is a text block. With hyphens, you can just make it some bullet points. Again, you can easily find other formatting, text formatting when you Google it. Let's just do it in case you need other edition or formats that you want for your project. I give you a few minutes if you want to add some comments, then I go to the next one.
Does the MD stand for meta?
Yes. Okay, so as you see in the next slide, I'm importing functions from PySpark SQL. So there's some functions that are unique to SQL, which is PySpark SQL, which is very similar to SQL. In the first line, I'm importing everything. With import star means everything. It's not that much efficient. You just make your cluster slower. As you see in the next line, I'm just importing the functions that I'm looking for. I want to work with event, count, and call. So as you see, the next lines basically make a loop through all of my columns and basically count how many empty cells existed in each column. And with show method, just show me the results. So as you see, it's a little different from Python commands. It just can count when C is null, which C is just basically my column names. Looking at the result, under H column, I have 177 empty cells. Under cabin, 687, and under embarked, just 2 cells. If you look at the comments that I put there, one easy way, you just use drop method and drop observations that have empty values. And here I said it might cause some bias. So I usually don't, I never recommend to drop any observation or columns unless, let's say 95% is the vast majority are empty. So that case is, you can advise someone to drop, otherwise you shouldn't. But why, could you give me an example why dropping a column or some observations would cause bias in your machine learning algorithm?
If I kind of do a study on what were the factors that affected the survival rate, if we drop, say, the cabin, and I recall last semester cabin was, but it was first class, second class, third class, right? So if we drop that, then we may not get a full understanding of whether people who are richer versus people who are poorer, was there any difference in the survival of these?
That's correct. Also, let me give you another example from last semester about Apple credit card. So people blame Apple Apple algorithm is biased toward female applicants. So one possible, I'm not working for Apple, but one reason could be, let's say you have a good amount of observation for both female and males. Let's say female applicants are not interested to respond to some questions. So for your female applicant, you have some empty cells. If you drop every observation that's empty, you may lose most of your female applicants. So when you want to train your model, you don't have enough observations for female, and it might cause some bias towards your female applicants because your model didn't have enough observation to be trained well. So let me just divide my data into sections of male applicants and female. Listen, there is a question. Tell me a question, Aditi, tell me a question that female applicants may not be interested to answer.
Age.
Age? Let's say there is an age. Maybe let's say I'll just throw a number. Let's say for men, 90% answer it, for female, maybe 20. So under age column, I have too many empty cells. For female, let's say I just drop 80% of it. Maybe for male, I drop 10%. So as you see, this is the only section of female applicants that I have, but this is the same portion of data that I have for male applicants. So we expect that our model is much more trained on male applicants than female applicants. So bias, having bias in your machine learning algorithms is a big reason we try to avoid dropping observations. So same goes here, but let's just do some visualizations. So from missing no, NO, I want to have a bar chart showing the proportion of my data in each column. So msno.bar, and I convert also my data set to pandas. And as you see, vast majority of cabin is empty. Age is a some portion, and also embark to have some emptiness. With matrix, you can basically see a distribution of emptiness in each column. Okay, now I want to impute these empty cells and have some numbers inside those empty cells. So these are numerical variables, and the different ways of imputing. Two famous ones are imputing with mean and median. Which one you recommend? Do you think let's say I want to impute age column. Do you think it's better to impute with mean or median? Why?
We had discussed that if we have an outlier observation, that the mean could be skewed.
Yes. Yes, very true. So if everything is fine, both of them should be okay. But let's say if you have some outliers, they will skew your mean value. But median is much more resistant towards those cases. Okay, so from scikit-learn.impute, I'm importing simple imputer. So let's wait a little bit here for you guys. Maybe you want to add some comments, then I go, or questions, then I go to the next part. Yes. Bar chart?
Yes. What's the right one? What does it mean?
Frankly speaking, I don't see any meaning. Maybe I'm wrong. It just seems to be something cute to me, but I mean, let me look at it. Maybe there's an interpretation for that, but from here, I don't get anything. Even if you look at emptiness in cabin and age, I cannot find a good association between them. Okay, let's look at the next block. The next block, I'm using two pandas to convert my data to panda format or panda-friendly format, and I want just make a copy, and this is a deep copy, and I assign to miswork. Then I make an imputer object with median, and as you see, I'm transforming my miswork data, and I'm looking at the column 5 to 6, which here means just 5. Because when you say 5 to 6, the first one is included, the second one is not included. So 5 to 6 means just 5. And if you look at here, first column is passenger ID 0, 1, 2, 3, 4, 5 is age column. And I'm just imputing that column. But here, just something extra. I have instead of just saying miswork equal data, I use the copy method and I just said this is a deep copy. So, but what is deep copy and what is the difference of copy from ordinary copy or shallow copy? So, in most of programs, softwares, when you say something equal to something, you don't create a new object. You just make a new address. Let me show it here. So let's say this is my data table. If in that line, I don't use the deep copy, miswork would be this. Let me see if I don't have any miswork. Or I have two names for this table. Both of them are fine. So basically, assign an address or name to the same shape or the object or that. But when you use deep copy method, this happens. So you have exactly same copy, but the name is miswork. In the first case, if I do something on the data, it would be reflected to miswork because both of them actually two different alias name to the same object. But this time, if I do something on data, it doesn't affect miswork. If I do something on the miswork, it won't affect data. Look at the next block. I explained through an example. So let's say I have old list one. It has 3 lists, and I assign it. I put the make. Okay, I think I should change here. Old list one. Okay. Old list two. I think there's some typos, but hopefully it works this time. Okay, so first one is old list one. It's a list of 3 lists, and then I said new list one equal old list one, and on new list one, I take object 2, and from object 2, I change the second indicator and I say it's equal 1. So it just means I change Hamid to 100 in the new list one. When I do print them, so I print old list one and its ID number, which just means location in the hard drive, and new list one and also its ID number. Look, both new list and old list change to 100. I just changed one of them, but the other one is also changed because both of them are one name to 2 different names to one object. And even you look at the ID number, it's exactly the same. I'm talking about this part, the part that is highlighted here. Again, as you see, I said old list one equal new list one. I changed items in new list one, but at the same time, it changed in the old list one because both of them 2 names for the exactly same object. In the second example, so let's see. Old list 2. think there's some issue here. Okay, that's fine. So look at the second one. I made a new list of three lists. So, and I said, now my new list 2 is basically a deep copy of my old list 2. And also this time I changed an item in old list 2. So instead of 200 here, I want to change it to BB. Now, when I print it, look what happens. One of the objects changed to BB, my old list changed, but not new list, because there are two different objects like here. When I change one of them, it doesn't affect the other one. Also, if you look at the IDs, old list 2 and new list 2, both of them have different IDs. It just means two different locations on your hard drive. There is some pros and cons. Sometimes you want to have a deep copy, sometimes you don't want. But just keep in mind, these are I think one of the questions they might ask you in the interviews. So what is the difference of deep copy with shallow copy or regular copy? Let's wait a little bit here in case you have questions or wants me to explain, or maybe you want to add some comments, then I go to the next one. Okay, again, let's look at the list of empty cells in my table. And again, this is a SQL-like command. It's not like Python. I know in Python there's another ways of doing that, but just see which one is you are more comfortable. I think you know Python much more than SQL probably. So I use a SQL command, but again, you don't have to do exactly what I did here. Maybe if you're more comfortable with Python codes, you can just do that. You don't have to use SQL-like commands. Again, okay, so for cabin and embark, I have some empty cells. Same as before. Here I also do imputing with mode. And I want to impute column 10 and after that. After doing all those imputations, as you see now, all of my cells are full. The frequency of empty cells are 0. Now everything is ready for just using machine learning algorithms. I can basically employ some algorithms to look over an independent variable and then predict my dependent variable. Looking at the columns, so with df.columns, I can see lists of my columns. Previous one, I showed you different ways of looking at your column names. Again, I might use different ways of doing same things, but just use the one that you're more comfortable with. Okay, so do you think passenger ID could be relevant for predicting someone's survival? Maybe ticket number, or maybe cabin number. I don't say, you might find some relationship, but for me, there is no intuitive connection between a ticket number and chance of somebody could survive. Unless, let's say, maybe they look at the different passenger class and maybe the ticket number has some associations, but for me, it doesn't seem to have an intuitive relationship. So with the select method, I'm just selecting the columns that makes more sense for me. Or if I make a machine learning algorithms, I can basically defend my result because for me, it makes sense that those columns has some associations. Sometimes I pause just in case you want to add comments or ask questions. So no worries, any good questions are good questions. Okay, looking at the columns that are picked, pclass, if you recall before, it just means passenger ticket class. Also, sex could be male or female. These values are a string, they are not numerical. You cannot use a string value in the machine learning algorithms. All of your inputs should be numerics. So I said that you need to make equivalent numerics. And one easy way is just doing one-hot encoding. Label encoding also works, but here I want to focus on one-hot encoding. If I open that, let me see. So here pclass is very straightforward. Even it looks like a numerical value, but we know class 3 doesn't mean 3 times more than 1, right? Although this is numeric, but it doesn't mean you cannot scale it or just do a numerical comparison. So we consider pclass as a categorical or a string columns, and same for sex, which is male and female. So let's make it even more difficult. Let's say for pclass, instead of having 1, 2, 3, maybe you want A, B, C. So there is 2 ways of dealing with such a string columns. The easiest one is label encoding, which you assign a number to each value. For example, for A, you assign maybe 1. For B, maybe 2. For C, maybe 3. So this is one way of doing that. In statistics, it's totally wrong. You cannot do it. But in machine learning, it's totally fine if you do label encoding like here. Another one, you do one-hot encoding. So pclass, let's say A, pclass B, pclass dash C. So first one, so for each basically for each category, you make a dummy variable, and on the dummy variable, you assign 1 or 0. 1 means your observation belongs to that category. 0 means doesn't. For example, A. So P class A would be 1 because it's class A, but it's not B and C. 0, 0. For B, it's not A, it is B, and it's not C. 0. What about A? Sorry, what about C? Could you say those numbers? 0, 0. I think you got the logic for the remaining observation. So there's two ways of dealing with such a situation. Here for P class, maybe you already can consider as a label encoding because you already have 1, 2, 3. But in case you don't have it, you can just easily do this. Other one, you make a dummy variable for each category, and you just fill it out based on the category of your observations. So, but generally speaking, you need to convert. Otherwise, your algorithm cannot process non-numerical values. So as you see from PySpark ML, I'm importing vector assembler and one-hot encoder and string indexer and vector indexer. These are just for first converting to your values to some index or categories, and then making associated dummy variables. For example, for 6, I tell Python for each category consider one index, and then I tell do one-hot encoding. So make basically make a vector of 0, 1 for the 6 index that I just defined, and same for embarked. So as you see for pclass, I didn't do that because I just saw it's okay to consider as a label encoding. So just assign a number for each category. But you can do similarly. You can just make one-hot encoding for pclass too. Okay, after indexing and making dummy variable or one-hot encoding for each category of my my categorical variable, I use a vector assembler. Just tell PySpark what are my independent variable and my dependent variable. So I'll just say input columns or independent variables are pclass, sex, vec, age, sp, parch, fair, embark, vec, and my dependent variable or output column is and this is my input and consider it as is the features that I'm used for prediction. Also from PySpark ML library, I'm importing logistic regression.
So once we use the one-hot encoder, suppose we print our top 10 rows. So will we see the original data like ETC or will we see the encoded?
You see these dummy values. I think there's some packages that you can convert them back. Okay, so here, my dependent variable, which is if somebody survived or didn't survive, has just 2 conditions or 2 categories. So I can easily use logistic regression. So logistic regression application is for the cases that you just have, your dependent variable just have 2 classification or 2 classes. So as you see here, I'm making logistic regression model, my features or input variables are coming from here using a vector assembler. Also, I'm saying that my label column or dependent variable is survived. By now, I just defined objects. I haven't applied on my model. So the reason I want to show you pipelines, but it's not the only way. So you don't have to make a pipeline. So in the pipeline, you define the objects, then you assign the order of running those function and objects. So as you see from PySpark ML, I'm importing pipeline. And I'm just saying, let's create a pipeline. First, I'm indexing my gender and embark. And I do one hot encoding. And I assign the vector of features. And at the end, I want to apply a logistic regression. I think making pipelines is one efficient way of doing your projects. You don't have to. Have you ever worked with the pipelines in your Python class? No? Oh, okay. It might be a little confusing. So maybe next time I don't use pipelines, but basically in pipeline, you first will define the functions or the steps that you want to do. In the pipeline, you put them in the order, and then you execute your order. I certainly recommend to just Google and read about pipeline. Maybe I make an assignment for you guys to basically read about pipelines, especially for big data projects. You need to have an idea what does a pipeline means. Here is a little straightforward. As you see, I first import some packages. I define some functions. Then I define the pipeline. Do you guys remember KNIME workflow? So look at this block of pipeline. This is like a workflow. I'm just saying that what should you do for each step. And you might remember I used to do right-click and execute whole of the pipeline. Same here. In KNIME, you said workflow. Here we call it pipeline. Okay, so yeah, so your next assignment about reading about pipelines. But again, we will have some other notebooks, so you don't have to do your project on over pipelines. But I strongly recommend to at least have some experiments. It helps you a lot. Okay, next, I'm basically splitting my data in 70-30%, 70% train, 30% test. As you see here I'm not running a pipeline. I'm just doing a simple division. But again, still I can do it over pipeline too. And I'm just saying that use my train data set and fit it over pipeline. So what it does, it goes here, it make a gender indexer, embark indexer, then it encodes my gender column and embark column, make a feature, make it basically the assembler here, which identify my input columns, and apply the logistic regression on top of it. So the fit model here has the outcome of my pipeline or workflow that I just defined earlier. Okay, I'll give you a few minutes in case you need to add some comments, then I go to the next one. Sure.
So now in the pipeline, we have the jobs like gender indexer and embark, like encoding, right? But we already
If you did it before, you don't have to do it again. Yeah, it's just two different ways of doing coding. So let's say if you do and if you did encoding in your, and after that you want to make a pipeline, you don't have to put it into your pipeline. Again, as you see, my pipeline doesn't have this split of train and test.
This pipeline right now, we're running it only on the train dynamic data, right?
Yes.
That is the 70% that they will use for training.
Yes. Okay, so after fitting that pipeline over my train set, I use the model for predicting both of my train set and test set. So the logic behind of that, so I want to have a good prediction for both my train and test. If both of them are high, it seems I have a more reliable model. I don't want to have a huge differences between the accuracy of train set and test set. Having said that, I'm fitting I'm transferring both my train set and data set through the model that I already trained. So train result and test result has the result of predictions. Now I want to evaluate my model. For evaluation, here I'm using accuracy and AUC. So for AUC, I need to import binary class classification evaluator. For accuracy, I need to import multi-class classification evaluator. Then I need to define my AUC evaluator object and also accuracy evaluator object. So for AUC, binary class classification, I define my prediction column and also actual label column. For accuracy, it's a little different. I just define 3 different steps. Let me give you a couple of minutes in case you need to add some comments. Then I go to the next one. Okay, let's look at the simple prediction. I'm from test result. I want to look at the survive and prediction. Okay, you find here. As you see here, it seems there is some mistake. For example, for some of the zeros, I predict 1. For some of them, it predicts correctly. And we also, after define the evaluator, I want to evaluate both test result and train results. So I want to look at the AUC of test, AUC of train, accuracy of test, and accuracy of train sets. Basically, up here, I define the empty objects of AUC and accuracy. Here, I just apply those evaluators on top of my train set and test set. After applying, now I can look at the results, see what is the AUC of test set, train set, accuracy of test, accuracy of train. So looking at the AUC in the next block, AUC of test is 0.738. AUC of train is 0.797. So do you think this is a good model or bad model based on this result? So why?
0.73 is closer to 1. We wanted an accuracy of 1 would be above 100%. So if it's like 73%, and only more.
Yeah, it could be very correct. So, but it also depends on your domain. In some cases, 0.7 something is not good. In some cases, it's good. Also, look at the difference of AUC between train set and test set. This is a 6% differences. It could be subjective. If I want to be too picky, I would say I don't see that much of reliability because 6% differences between train and test. And this is my previous data, my historical data. What if I introduce a new data? Maybe instead of 73, it could be like 60, 62. At least here, I don't have any evidence that these two AUC are close. Same for accuracy. My accuracy of test set is 74, train is 80%. It's about 5-6% differences. So still, maybe depends on the domain. 70-80% accuracy could be okay, but still there is a gap between train set and test set. So I don't have enough evidence for saying this is a reliable model.
Professor, for the sake of our project, when we're calculating the accuracy of our model, when would we say that it's good? Because we wouldn't know for sure about the domain, right?
Yeah, I mean, you just need to generally talk about that. I mean, I don't expect you to know too much about the domain. Just say about your general feeling and or subjective feeling. Also, you need to talk about differences of train and test. And maybe in your case, you would say 6% is okay. That's fine, but at least you need to talk about that. Okay, so do you have a question?
Oh, no.
Okay.
I was just wondering how much difference of the test and chain AUC is tolerable.
It's still subjective, but you need to talk about that. Okay, so here we talk about one way of discussing about reliability of your model, but the better way is just consider cross-validation. You might remember we had 5-fold cross-validation in the previous class, and we look at the accuracy of each fold. If all the accuracies are high and close to each other, it seems we have a reliable model. So if it's enough reliable, you can apply it for future use. So next step could be look at the n-fold cross-validation and see how's the performance of your model on different folds. Here we have limited number of features, but we still did some manual feature selections. I didn't use all the features. I just said, with vector assembler, I just picked some variables that makes more sense to me. Actually, you should do that. First, you should have your intuition and just pick the columns that you could at least discuss about them. Then, in some cases, you might have 200 variables. So in such cases, your model is prone to overfitting. What does overfitting mean? Means your model might be very good for train set, but you cannot generalize it for test set. So in those cases, we don't want to use all of those 200 variables. We want to pick the one that are the most relevant. So feature selection approaches is a good one for you to just, instead of focusing all the variables, pick the one that could be more, has most relevance. And a way of improving your predictive performance using different algorithms. Here I used logistic regression. Maybe if I use neural network, instead of 70-80% accuracy or AUC, it could be 90-something, or at least the gap between train and test could be closer. And the last one, which is above the content for this class, is tuning the algorithms. Do you guys remember in the previous class I talked about neural network? So neural network, you might have different hidden layers. You might have different activation function. So you can go inside your model and change some settings. Or you might remember I talked about decision tree before. So tuning algorithms, changing the settings inside the algorithm is another way. But in this class, we will have some notebooks that I talk about enforcement validation, feature selection, and maybe we try different algorithms. For your final project, you should have 3 different approaches to improve your performance. One could be different algorithms, and the one maybe different data preparation. Maybe you do different types of imputations, or even you tune your algorithms. So maybe you change some settings inside your algorithms. At least I need to see you try 2 different approaches for improving your predictive performance. What I mean predictive performance, accuracy, sensitivity, AUC, those kind of things. If you can, that's good. If you cannot, that's fine too. So you don't lose any credit if you cannot improve it. Okay, so again, I will give you some assignments. One is about pipelines. So I ask you to read about pipelines. This is at this time you don't feel that much of necessity, but this is a really important skill later on. So, and more specifically for machine learning projects, sometimes you need to just go back and forth several times. So instead of doing everything, you just go to your pipeline and change some parts of your pipeline instead of just putting like 10,000 lines of the code each time. Maybe in your pipeline, just change a little bit. So pipeline is an important skill. In Python, Java, even R, everywhere you see a kind of pipelines. So I give you that assignment, and then you might have several more assignments in how you present your works. That's another important skill that you need to improve. Okay, any questions? Let's say, I don't also see any question from your friends over Zoom. Okay, so the plan for the next sessions, I do some notebooks and we dig into some methods. Which you will see several experiments. If we have time, which I think I will have, so in the last weeks we have some experiment over Amazon AWS. If you have time, maybe again I go to local installation, and also we make a basically what they call it trial contract with a company that provides virtual PC for Hadoop environment. That one is not necessary, but still we have a free trial. Why not? If you want to have some experiment with that, that's totally fine too. Okay, that's for today. Thank you very much, and see you in the next session.
project phase 2.
Uh-huh.